Here's problem number 14 from section 3.3. We're asked to find dy dx by two different methods, and let's go ahead and try this out. Let's take the derivative with respect to x of both sides of the equation. X squared plus 3 all over x. And they're going to ask us to use the quotient rule. Now the derivative of y with respect to x is dy dx. The derivative of this is going to be the bottom times the derivative of the top minus the top multiplied by the derivative of the bottom, and all of this is over the bottom squared. So what do we get? We get x multiplied by the derivative of this, and I can break this down even further. The derivative of x squared plus the derivative of 3 minus this multiplied derivative of x, which is 1, and this is all over x squared. So what do we get here? The derivative of x squared is 2x. The derivative of 3 is 0, so I won't write that down. And if I expand that out, I end up with just x squared plus 3 all over x squared. I get 2x squared minus x squared minus 3 over x squared. Or I get x squared minus 3 over x squared. Alright, and perhaps I clean that up one more time as x squared over x squared minus 3 over x squared, or 1 minus 3 over x squared. So there's a solution using the quotient rule. Now they asked us to do this problem again, but what would happen if we cleaned it up first before we applied the derivative? What if we took this expression and changed it into its equivalent of x plus 3 over x? What happens if we take the derivative with respect to x of both sides of that expression? X plus 3 over x. Well, we still get dy dx. The derivative with respect to x of x plus the derivative with respect to x of 3 over x. And here we get a 1. Here we're going to pull out the common multiplier of 3 and take the derivative of, and I'm going to rewrite this as x to the negative 1. 3 times the derivative of x negative 1. Power rule says bring the power in front, reduce the power by 1. Or in other words, I end up with 1 minus 3 over x squared. And you can see that these two absolutely match.